on Facebook.
Wow, that's so amazing.
I
I've
know,
never done this before. How fun.
It's super fun. Now I'm going to go to our page now that it's going live and just, maybe Lonnie, you could do that for me. A lot of times what I do is I forward it and just let everybody know. Let's see. Let's see, it's coming up. Hello, everyone. We're just about to get started and it's live. Yay. Okay. You
All right.
All right. Well, I'll kick us off.
Okay.
Yeah, we have, we're 1 minute. We're 1 minute and then we'll kick off. We'll give everybody less than 1 minute and then we'll
oh yeah, I can see.
Yeah, just. We'll start at 7 o'clock on the dot. And it's 7 o'clock. Hello, everyone. Good evening and welcome. We're super, super excited this evening. We have a special guest, Anna Johnson, who is here to tell us all about the fun that we can have this summer teaching our kiddos elementary math and games and activities. And those of us who have kids that may be, older than elementary, but still learning math skills, we can be able to leverage some of the fun things that she's going to share with us this evening. Many of you who've joined or who have not joined, I'm Lisa Valerio. I'm the founder of the Phoenicia Foundation. We're an organization based in California. We're a nonprofit 501c3, and we put on trainings and workshops and we do outreach to those who are underserved and those who may have services, but we really try to focus for those who may not be able to get services. And anybody who's interested in learning more, please go to our Facebook page or to our website at phoeniciafoundation.org. And anybody who knows, anybody who'd be interested in continuing to support our needs, please refer them to our site and see if they'd be willing to make a donation so we can continue to put on workshops like we've been doing and how we want to continue to do. So with that, I'm not going to jabber any longer. I'm going to let Anna, so we can leverage this amazing hour that we're going to have with Anna, who I've had the pleasure to put on workshops now with Anna, maybe 4 or 5 different times over the past maybe 6-7 years.
Yeah.
Some time. And it's such a pleasure to always be able to work with her and partner with her on different activities. And I learn something new every single time. So with that, Anna, I'm going to turn off my camera and leave it to you. And then about 45 minutes in, I'll just give a little reminder that because we want to make sure we have plenty of time for Q&A. And we've got who's also on the line this evening, and she's going to be in the behind the scenes helping us answer any questions and compile questions. So with that, Anna, thanks.
Thanks, Lisa. Thank you.
You're welcome.
I'm so excited to be here. And Lisa, you will have an opportunity to play a game with me during this session, so don't go too far.
Okay. I won't go anywhere. I'm just not going to share my video. I'll let you, we want the focus to be on you.
All right. I am so excited to be here and I love math. I can't wait to share all that I love with all of you. So let's get started. I am a educational therapist. And if that's a new kind of term for you, it is a discipline that was started in the United States. I get to work with kids with learning differences, and think of it as a special education teacher. But my background is really on how the brain learns. Special education teachers in the United States have to deal with lots of different moving parts. But for educational therapists, we really focus on how kids learn and tailoring instruction so that they can learn best. And these are typically kids with dyslexia, dyscalculia, dysgraphia, all the kind of learning disabilities that go along with learning differently. I'm also a math specialist at our local middle school, and I work with middle school teachers on supporting their students and tailoring instructions. So that's kind of me in a nutshell, but let's get to the fun. Oh, let's see. Oh, okay. So I love math for a whole variety of reasons, but this is probably the top reason why I like math and working with students. I feel like when I get to do math with kids, I get an intimate window into how they problem solve. It doesn't matter if they get the right answer or the wrong answer. I want to know what they're thinking, how they're problem solving, and math gives me a great opportunity to do that in a way that other kinds of academic disciplines don't do. And I'm also inspired by my kiddos. So here is the look of my oldest, who is now 14. When she does math, and maybe it's confusing, and then there's this aha moment. This is kind of the classic aha, like wonder. I just love it. I get to do that every day and see their look on their face when they finally get like this epiphany happens. It's so great. It's such a classic expression. It does not change if you are 3, 13, or 30. And there's that other one. They think so differently. This is my youngest, who is now 10. Loving life, trying, experimenting. And this is, these are 2 special kiddos that really bring math to life to me and give me purpose. And then I just want to say, because I don't know, when I was growing up, I always heard, well, I'm not a math person, or girls can't do math, boys are better at math. And I want you to know that all humans are born to do math. It is something that is innate in all of us. And while some of us have to practice more than others, everybody can do math. Everybody is born to do it. So just if there's one thing that you leave tonight's webinar or this morning's webinar, I want you to know that you can do math, your kids can do math, and everybody is born to do math. All right, so starting this presentation, I want to give you the foundation, kind of the secret sauce of what is behind these games and how kids, what's the developmental progression for children through adulthood in learning and understanding number. It's called the number sense trajectory. And once you have these kind of the secret sauce or the building blocks, you can create any game, any activity for any kid at any age using these foundational kind of secret sauce. So what is number sense? Number sense refers to a child's fluency and flexibility with numbers. And it gives them an understanding of what numbers mean, and it helps them make comparisons between numbers. And so it's just kind of an innate knowledge or feeling, a sense of what numbers are, what magnitude is, how big something is, how small something might be. This is number sense, and it develops over time. It's not necessarily learned entirely. There are kind of these milestones where it just kind of clicks, and a student or a child is receptive to absorbing additional information about number. And so here is, and this is really small, I wish it were bigger, but I wanted to take the trajectories so that you can see all the different parts of number sense. And we'll begin with sabotizing, which is being able to visually see and recognize a quantity and instantly recognize the number. So we're going to play a game right now. I'm going to show some dots really quick, and then I'm going to show an orange screen. And in the chat window, I want you to say how many dots you saw. Okay, 3, 2, 1. All right, how many dots do you think you saw. Oh, I see lots of people. Oh, the chat's going crazy. And let me see. Let's see. What are people saying? Oh, I see 7. I see 8. I see 7, 7, 8, 8, 7, 6, 7. Yep. Okay. So what I'm going to do is I am going to, I'm going to put those dots. I went too fast. I'm going to put those same dots and I'm going to put them into a structure. And so once I put them into a structure, you might be able to verify how many dots there are. Okay, let me show it to you quickly. Okay, 1, 2, 3. All right. How many dots did you see now? Oh. 7, 7, 7, 7, 7, 7, 8. Oh, 8, 7, 7. Yes. Okay. So let me tell you what's going on in that brain and where it might be like for a kiddo. Knowing the number of dots. Oops. There we go. So I took those 7 dots that are kind of all spread out. And what's happening in an adult brain is that we are gathering those, we're starting to see those dots. Ooh, I'm going to use the annotate and see, let's see. Spotlight, eraser, format. What is this spot? Ooh, draw. Let's see if I can do this. We might see these dots. Ooh, that's cool. Green, my favorite color. We might see these dots. Our brain might be clumping these dots into patterns. And you may not see these dots in these two groups of 3 and a 1. You might see them this way. Somebody else is going to see them some other way, but your brain is able to kind of clump those dots. But in a child's brain, that is not readily accessible yet, because they're in a developmental progression where they're not organizing that information, these dots, and making sense of them. And so as teachers or parents, when we expose them to dots and different spatial variations, we're kind of training the brain to start recognizing these numbers. Okay, let me see. Can I get rid of the annotation? Let's see. Oh, where'd it go? Sorry. I'm losing my cursor. Can I stop annotating? No more annotate. Oh, there it goes. Okay. Oh, now I have to get rid of it. How do I erase it? Eraser. Oh, good. Oh, good. Okay. Thank you for your patience. And so one of the things that you can do is when you take these dot patterns, and I have a bunch of dot cards, we can impose a structure on for kids so that they can start making sense of these numbers and developing their subitizing skills. Here's another one, a 10 frame. These were created by John Vanderwall. And here, he was so smart. Here's the structure. And we know when that structure is full, it's 10. And so he thought, well, in an adult's brain, we can move things and make movies in our brain. But here, kids need opportunities to experience that. They know that there's 2 out here. Oh, there's 2 empty spaces, automatically say 10. So that's subitizing. There are variations of getting to more complexity for subitizing, but that's it kind of in a nutshell. If you see some dots, you're automatically able to say what they are, and you move on, and it gets complex over time. You can do 10s and 1s or 100s, all visual representations of number. All right. Okay, so if you want more dots, you can create your own dot patterns, or you can just Google John Vanderwall or Vanderwall cards or subitizing cards and create your own. I have a whole collection. I use them all the time. I love them. Yeah. you can, here's some other patterns. That's always instantly 4. Okay. So here we go. Here's some noticeable patterns again that you might see on dice. This is from a game called Toto Math, which I'll demonstrate later. But you can see this 5. A young child might count these one by one, these dots, 1, 2, 3, 4, 5. But you know, with more opportunities, they're going to remember that that pattern just means 5. All right. Second part of the number sense trajectory is comparison. So it's being able to compare quantities by identifying which has more and which has less. So here are some game ideas using my dot cards. I can ask a student, which card has more? Which card has the least? This one. Now it's interesting for kids who are developing this comparison. Let's say I had a card, this one is 7, this card is 8. It's not necessarily easily to identify which card is more. And so this is a little bit more complex. A typical game is using a deck of cards. I don't know if you guys play peace, or some people call it war, where 2 players, 3 players split the deck of 52 cards, and then you flip it over, and whoever has the most takes the whole pile. You can do this with addition. 2 cards, you add them, and then you compare against the other players. You can do it with multiplication. Varying ways of being able to compare based on the proficiency level of the students that you're working with. And then using pebbles or coins, that's another thing. Ooh, I have these blocks. I have 4 blocks. And I can ask a kid, hey, can you give me a number, give me a pile of blocks that's more than this or less than this? But these are ways to play comparison games. And then let's say you're using numerals only, like 35 and 53. This can be kind of hard if you aren't making pictures or don't understand that this is 10 blocks all in a line, that 53 has 5 of these 10s plus 3 additional blocks, and that 35 is 3 of these 10s plus 5 of these blocks. Right off the bat, if you do it in abstract, some students aren't going to be able to, they might be flipping those digits around. But once you make meaning of it by creating models using physical objects, the more opportunities you do that, then they're going to be able to see, they can compare the quantity a little bit easier and make meaning of what those numbers are. All right. Third thing, number sense trajectory is counting. And this is oral counting. I'm talking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and backwards. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And these oral counting routines, if you're a teacher, you can do this in between subjects or transition periods where you can choral count as a whole class, or you can take turns counting one by one in a circle. Passing a beanbag. I call this my magic 10 wand. I will pass it around the room. And if you have it, you get to say your number and go. But we can make these counting routines very sophisticated, that it does not have to be simple 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and back, although that's totally appropriate for a 5-year-old. Let's say that you're a 5th grader and you're counting by 8s. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, which is 1. 1 1/8, 2 1/8. What is the pattern? And what if you're skipping by 2 8s, 1/8, 3 8s, 5 8s, 7 8s? Oh, 1 1/8. These can get very complex, but there is value in doing these oral counting routines and separating that from some of the traditional worksheet materials that you might be doing that help build this number sense. And then a variation on this is, let me give you a pattern. I used to do this driving in the car with my kids, driving them to school. It's like, 999,999. What comes next? You know, that's a hard transition number. You know, 1 million comes next. And they might be like, I don't know. Well, let's look at the pattern. So, or what comes before? Hey, what comes before 100? 99. Okay. But you know, that's a puzzle for a lot of kids. Anyway, oral counting routines, easy to slip in during the day, at home, at the beach, on the way to the grocery store, whatever you're doing, you can be doing these oral counting routines with the kiddos. Oh, brushing teeth is always another one too. Okay, one-to-one correspondence. I'm going to share a video. Let's look. Let's see. You are sharing screen. Let me stop share and restart share using the video. Hold on. Let's see. I'll do this. Share. Am I sharing? Oh, no. Thanks for your patience, everyone. I want maybe this one, Google Chrome. Share. Yes, okay. Let me know when you can see that. Can everybody see the black screen that says one-to-one correspondence? I hope so.
You can see it, Anna.
Okay, awesome. I'm gonna press play. Let's watch this short video together.
Are you sure? You moved one of the blocks. You can move them if you want. You want to move them? So how many altogether? 1, 2, 3. How many altogether? 1, 2, 3. So there are how many blocks on your map? 3 blocks, right. How many are there now? If I put some more on. 1, 2, 3, 4, 5, 6.
All right. So lots going on in there. I noticed that he's a young boy, probably 4, and he's saying 1, 2, 3, 4, but there's 3 blocks on the table. And then he starts to touch them and he's still counting to 4. This is very common. Matching up the oral language of number with the objects, you know, they need to marry at some point. And this is kind of the age where that happens. And so that is called one-to-one correspondence, and you see him touching. So a lot of, at that stage where kids are touching the objects and counting them one by one, this is the one-to-one counting stage. And so let me stop sharing and go back to my presentation. Is this it? No. I'm sharing my screen. Can you see the one-to-one correspondence games? Is everybody seeing this?
Yes, we can.
Oh, yay. Yep. Okay. Yep. So another game that you can do for one-to-one correspondence. It's one of my favorite when I was working in a preschool and working with kindergartners. I would bring in, I have these beautiful Mexican paper flowers, and I would bring in little jars, you know, from, you know, the condiments that we bought at the grocery store, and they were just empty. And so I would bring a clump of flowers, and I would bring some jars, and I would ask kids, can you put these flowers one-to-one with the jars? Do we have enough jars? I don't know. How many flowers do we have? Well, we have 5 flowers. Well, how many jars do we have? They count them, they're 4. Well, is there enough jars? Is there enough flowers? Let's do it. So when they counted by putting a flower in each jar, this helps solidify this one-to-one correspondence, that there is 1 flower for 1 jar. And I'm consequently growing a cut garden right now. I have zinnias and sunflowers, and so like I love flowers. But this is fun for kids to play. And then I won't play the next video because I don't know that we'll have time. We'll go on to other stuff. But another game to play is Match Me. And so I might say, hey kids, can you match me? Match 5. And what I'm looking at is 5 fingers, or it could be, you know, 5 fingers, or it could be 5 fingers. But this match me, you know, or if we're really struggling, then I might say, hey, can you match me 5 fingers? And we'll go 1, 2, 3, 4, 5, so that we're all matching those fingers. Anyway, that's the one-to-one correspondence. So let's move on. The next one is cardinality. It tells us how many are in a set and in a set of objects. And the last word that's counted in the sequence is the quantity of the set. But it also, one thing that, and I'll show another video and you'll see, but one thing that's in common from going from one-to-one correspondence to cardinality is be like, okay, this is 10. What if I add 1 more? A kid who's still at the one-to-one correspondence, they're going to go back and count 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. A kid with cardinality will say, oh, you told me this was 10. And 1 more is 11. Okay, so let's watch this video. Okay. Stop share. Share screen. Where's the Google Chrome? Okay.
Anna, we're not hearing any sound.
5.
How about now?
All right. What's this number?
Yeah, we can hear it now.
Okay, we'll start over.
And maybe I'm wondering your headset is causing the.
Can you hear it now? I was muted. I don't.
No, go for it. Try it again.
Okay. All right.
So then
We can hear.
Okay. All right. Are you ready? Okay. What's the number right before 6? What's that one? 5? You sure, huh? All right. What's this number? 10. What's the number right before 10? 1, 2, 11. What number was it? What number was it? What do you call this number? Remember? 9. This is 9. This is 10. You said 11. 11 would be right here. All right. What's this number? 2. What's this one all the way up here? 6. You feel very sure about that. And you were right.
All right, I'm going to make a couple comments about this video and this idea of cardinality. Just like the number sense trajectory in terms of the developmental progression, This student clearly has a good number sense between 1 and 6. She knew right away where that 6 was. But when you get to numbers bigger than 6, then it was kind of fuzzy. And that's the same way from, you know, for all numbers. So a fifth grader who might have great number sense of 1 to 1,000 may not have such great number sense of fractions or decimals or numbers greater than 100,000. And so practicing cardinality of what comes next, of 999, what comes next, 1,000, that these are important games to adapt no matter what grade you are at in the elementary sphere. All right, so I'll stop sharing that and start sharing my PowerPoint. Oh, why? Let's see.
We can see it now, Anna.
Okay, the number sense trajectory. Okay, so we did cardinality. And let's move on. Okay, hierarchical inclusion. And this is like, these are my favorite games to play with kids. And I'm going to show 3 different kinds. One for a kindergartner, one that you and I are going to play, Lisa, and one that people can find on the internet that's free and you can play with your own kids. Okay, so hierarchical inclusion is kind of part whole thinking. And so a popular game with young kids is called Bears in a Cave. Maybe you play it, but I'm going to show you a video. Share screen. Where's the Google Chrome? Here we go. All right. Okay, here we go.
How many friends want to play hide and go seek? Okay, so 6 friends are going to play hide and go seek. Rana, will you close your eyes? And some of them are going to hide. Close your eyes. Open up. How many bears are hiding in the cave? Rana, can I save that picture for art time? I really like that bear. So how about my picture? Do you think you could show me how many are in the cave? Remember there were 6? Well, I see 3 of them. That's why I did 1, 2, 3. What would be in here? If I put 1 bear in here, is that enough? Is that all 6 friends? No.
They left me behind, and there's the 6 in there, and they left, and 6 leaves behind 5, 4, 3. So there's 6 of them in there.
6 would be all of the bears. They can't all be in there because I see 3. If I showed you 6 fingers, which is the part of bears you see?
I see 3 of them.
You see 3. So I'm going to put those, we already counted those. How many haven't we counted?
We didn't count the ones in the cave.
Yeah, how many do we still have to count? We've already counted 3.
Can't figure this out.
Would you like to look in the cave and see?
3.
There were 3.
All right. So there was 6 total, and then they had 3 went in the cave, but those are hidden and 3 remain. So having that part whole relationship is another developmental milestone in the number sense trajectory. And so this is a fun game to play with kids. And I liked, one thing to note that I liked about the teacher is that she didn't spoon feed him the answer right away. She gave him 2 different strategies. One is to draw a picture, see if he can make sense of it. And then the second was she used her fingers. I probably would have, before I offered to say, well, let's look what's in the tent. I probably would have gotten out some blocks or some other bears, like, can you replicate this? Let's try to replicate this and see if we can. It's important to kind of leave little breadcrumbs when a kid is struggling to find a solution right away. It's okay to just kind of lean back and let him, or the student, could be her, kind of puzzle and tease it out, you know. So that's Bears in the Cave. And Lisa, let's play a game. It's called Salute. I'll teach you how to play. I have a deck of cards. And we're going to choose a target number called number 10, okay? And I'm going to hold a card up on my head. I know what this is because my glasses on and I can see myself in the screen. But you're going to see this number, and the target number is 10. So this plus the number that you need to figure out would equal 10. So what number plus this is 10?
4.
Okay, so you say 4, then I have to figure it out. This card must be 6. Okay, so I'm going to take off my glasses now, and I'm going to hold this. I can't see because I'm blind as a bat. What number is that?
10.
Oh, so this is, no, I don't have a 0. We're trying to make the target number. Is this?
The target number is 10, right?
Yeah, the target number is 10.
So turn your card around.
Oh, this is 10. No, so 0 plus 10 is 10. So I'm supposed to guess. You have to.
Got it.
Let's try it one more time.
All right, so you need to guess that number, right?
I need to guess this number, but you need
1.
Oh, this is 9.
Yep.
Okay. Another one.
7.
Oh, 3. Okay, so you can make this harder by doing multiplication facts. So let's use the multiplier is times 2. So you're going to times 2 this, and then tell me what the product is, and I'm going to guess what this is.
Okay, 8.
So this is 4.
Yep.
Okay.
10.
5. Okay, so that's how you play Salute. I'll go back to my presentation. That's a fun kind of hierarchical inclusion, the addition one. Let me share a fun game. This is called Splat, and these are free to download from Steve Wyborny. Okay. And this I'm using as fractions because a lot of people don't think of fractions as numbers or like this strange thing. They aren't, something to think about as a number, but they are numbers. And so this is practicing hierarchical inclusion with fractions. So I notice on the screen, there are some halves and there's some wholes. And if I counted them all together, there's 4 blue ones. And if I combine the halves, the yellow halves, they make, if I combine two of them, they make another whole. So there's a total, if I counted them up, I don't want to use the annotate tool because I'm worried that I'm going to not figure that out again. There's 7. Okay, so then let's see what the what number does this represent? 7. Okay, and then all the kids go splat. Now, how much is under the splat? Well, and this is good for adults or for students too. Anyone is to think aloud. Let's think aloud. Let's talk math. We don't have to just all put it on a piece of paper and show it. So I'm just going to do my think aloud. Okay, I know there were 7 to begin with, and there is 2.5 showing. So I know that 2 and 5 is 7, but I've got this half. So 2.5 must be 4.5. And what typically happens for some kids is that they're really going to have to draw this out. And it says, how else would you know? Well, I can think of 3. That half is, almost 1. There's almost 3 showing, almost. So 3 and 4 is 7, but it's almost 3. It's 2.5. So it's 4.5. That other half lives under the splat. And there you have, we've got 4.5 under the splat. And these are free to download. Steve Wyborny, you can see at the bottom of the screen, and he has this game called Splat. They're leveled. They're great for kids of any age. They come in Google Docs and in PowerPoint. Love them. Let's go back to the presentation, but not that one. How do I? Okay. And my Magic 10 wand. This is a game I like to play at the end of the day for the classroom if we're doing some kind of community event. It's a 10 wand, 10 blocks. And we take turns hiding blocks behind our back and then showing the group how many blocks are left. And here you'll see there's 8. Some kids will know, well, you have 1 yellow block and 1 blue block. I'm like, well, let's see. Oh, yes, we do. Okay, that's another one that kind of focuses and hones in on hierarchical inclusion. All right, let's keep going. And the last part of the number sense trajectory is number conservation. And this is really, I don't have a game that kind of does this to practice number conservation. It's essentially an experiment that Piaget did with students to see at what age they this kind of phenomenon happens. So I'll kind of talk you through it. He would put 5 objects or some number of objects all tightly together and ask, how many is there? And in our instance, there's 5 at the top. And then he would say, okay, those are 5. I'm going to spread them out. And he's going to say, and then he asks, how many are there now? Are there more now or less? And so kids would say there's more because of this spatial kind of phenomenon. This is what their reasoning was, that there was more of these objects just because he spaced them out. And then there's a part in a child's development where they just know 5 is 5. It doesn't matter what arrangement you give me, they're just going to be 5. So there's really no games to play other than to replicate the study itself, which is kind of fun. But that's number conservation. All right, so I have some recommended math materials to use at home and in the classroom. The first one is Total Math. And it's an app both on Android and iOS. Let's see, here we go. I will share that one game. I'll share it really quick. So this is Total Math. It's a suite of games, and a huge library of games from preschool to middle of 3rd grade, but great for independent practice. There's daily practice that kids can do. It's 10 to 15 minutes. It is tailored to their own levels that are predetermined by the adult setting up the account. I like going into free choice and playing side by side with both my kids when they were younger, and with students. Here, I'll play this domino math, which practices both the subitizing and the part whole thinking. So we've got make 5, and 1 and 4 of these patterns make 5. I'll make a mistake so you can kind of see how that happens. I really like that the mistake is subtle. What happens sometimes with these games is that kids really like to make mistakes because they get this huge reward. This game doesn't do that. So, but you can see all the different levels, 1 through 11, that the kids can play. And then I really liked this one. This one's new. It's multiplication beads. You can see it's levels 1 through 16, and it kind of counts. It helps with the oral counting, skip counting, but also marrying that with the abstract representation. So here you kind of 3 times 1, where's 2? 3 times, where's 3 times? 3 times 3, 3 times 4, 3 times 5. And you can see that you get the product at the end. 3 times 5, 3 times 6, 3 times 7, 3 times 8, 3 times 9, 3 times 10. And what I would do is reinforce 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. I'm loving this game. I love this game. And then they give it going kind of backwards, where you're doing 3, 6, 9, 12, 12, 15, 18, 21, 24, 27, 30. And it goes the other way, where it shows the representation, or how you would write the equation. All right, so that's total math. It's if you're pre-K through 2nd or 3rd, middle of 3rd grade, this is great. Years of content, especially if you're starting at the younger, then they can lots of room to grow, and it's great for kids who are struggling in math. And then another app that I really like is called Bedtime Math. This is free. It's a free website. It's a free for Android, and it's free for iOS. And it comes on, both of these apps come on either a phone, or I'm demoing this on an iPad right now. But it starts with a story. You can select a story from the left-hand side, or you can just do problem of the day. This is talking about pizzas, but it has differentiated word problems that go with it. And so my agreement with my 10-year-old is the sky's the limit's kind of hard for her. So, and it's hard for me. So she says, I'll do all the wee ones, little ones, big kids ones, and you get to do the sky's the limit. And she gets to kind of sometimes either see me blow it out of the water, and I'm like, and this and this and this, and then other times I'm like, I need help, I need to draw pictures, I need to do a model. So you can kind of see how the stories go, but the important part is that I'm modeling for my kid perseverance in attacking problems that I may find hard. She gets to see me problem solve. I'm doing think alouds. I am modeling for her what I hope that she will do when she approaches math. I show no fear. It's okay to make mistakes. It's okay to kill it. Yeah. And be really proud of myself when that happens. Okay, so those are two apps that I really like. I'm going to stop sharing this and go back to the presentation. There are some physical items that I really like that I always have handy. Rec and Recs. And I don't have those. Those are in my kitchen right now. But these are great math manipulatives that deserves its own webinar. But I put Christina Tondevald is an amazing math educator. And she has a YouTube video that talks about how to use Rec and Recs. But this is another way to sabotage and for counting and practicing all kind of the number sense activities between 1 and 5, 1 and 10, 1 and 20, and 1 through 100. And I think she has 1 through 50 too. So that's in my must-have arsenal. Obviously, a playing deck of cards. I always have those. I have my bag of dice. I carry this. I have 5 dice in my wallet at all times to play games. That's in my must-have. These books by these authors, Anna's math games, are beautiful illustrations that are great storybooks to have in circle time or to cuddle up in bed and to just look through the pictures and notice and wonder all the mathematical things that you see in the books. And then The Grapes of Math by Greg Tang. He's a math educator in the United States, and he has these riddles. And so his whole series of books are great for elementary school. And for all, I mean, a 5th grader would love it as much as a kindergartner. There's that book, those books are good for everybody. And then this one, The Number Devil, I just finished a 2.5 week unit with middle schoolers, grades 6, 7, and 8. I think it's appropriate for 5th grade too. Sometimes it's good to mix up math class and read a novel, but these cover big ideas. You do not have to be able to calculate decimals or, know all your algorithms or even all your math facts to really enjoy this. It goes over concepts of 0 and infinity. It makes fun and light of Fibonacci numbers. It's just, I love this book. I've read it 3 times now. And then, let's see, Lisa, we've got, can I go on? These will be short.
Yeah, we can go on because I think people are listening really intently. We don't have that many questions coming in yet, but those of you, we're continuing to go through this. If you can start to ask some of your questions in the Q&A. I know we've answered some of them, but yeah, continue, Anna. Thanks.
Okay.
Yeah.
So these are more developmental considerations that don't have anything to do with number sense, but something to be aware of. The first one is the developmental progression from concrete to abstract. And so it's a lot of folks think, well, only, really young children need these concrete materials to touch and to hold and to make models. And the truth is that mathematicians through the centuries have been making physical models to try and test their thinking. What's the, how do you describe gravity? Or what's the formula for gravity? I have to make a machine in order to figure out what gravity is. I mean, these mathematical concepts live in physical universe. They are a representation of what happens in our natural world. So just thinking that these are toys for young children, no. We need to think of concrete objects that they are available for everybody. And then we've got the pictures, the representational, putting pen to paper. And we saw that in The Bear in the Cave. These are other ways that we can express our thinking in pictures. And finally, there's the abstract. And so when I'm teaching, I try to bridge all three of these together, because I don't know if my learners are needing this or the pictures or the abstract, or they need someone to model the marriage of all three mean the same thing. So just be mindful of that. We don't all live in an abstract world. That is something to work towards. And then we know this just from, centuries of human development, that cultures from all over the world have these pictorial representations of numbers that are very sophisticated. These are Egyptian, there's Mayan. I believe Mayan had representations of fractions, baskets that weren't really seen in other cultures. And so very sophisticated ideas and reflections in pictures, that just because a student might be reflecting their mathematical thinking in pictures, they are somewhat behind or needing extra attention because they aren't able to reflect their thinking and writing abstract numbers. Pictures are an avenue and access point for lots of different learners. Okay, and then one thing to think about as an adult, projecting values onto students and young children, or even our older kids. I knew as I was growing up, I was taught that math is a skill. It is practicing procedures and memorizing my math facts. And that once I had all the skills, then I could then apply them to, hard math. And then there's this other side of thinking, is that, is math a reflection of thinking? And based on my own mathematical journey and parenting, and now knowing that humans are born to do math, I try to focus on understanding. Even at ages 3, 4, and 5, young children can demonstrate their understanding of math, even though we're not using, abstract symbols of what's more and what's less. These are huge, big concepts that even young children can do, and that we don't have to wait for them to know what the numeral 1 or 100 means. Anyway, keep that in self-reflection of how you're going to how your belief system may be imposed on your students, and whether or not that's okay. And I'm still in the growth mode of trying to figure that all out too. And then I think of math as a language unto itself, just like English, just like HTML, like coding, it is its own language. And so what we know when learning other languages, that we listen a lot. Babies listen to their parents and siblings talking, and then babies start to babble and they start to talk themselves. And it's not until much later that they are reading and writing. But when I look at my own math journey and how I learned math, this is how I learned math. I listened to the teacher lecture. I was expected to read and write in abstract symbols very early. And then it wasn't until later, until I proved myself with math facts and procedures, that I could talk it. And so what I'm proposing, actually, I'm not proposing, but Graham Fletcher did at this amazing Ignite talk back in 2015, was that we flip this model that we use think alouds as teachers and parents, you know, to model what's inside our head, what's going on, and how we problem solve. And that we have conversations with kids to talk about it and encourage them to talk through what they're thinking. And then we think about reading and writing math. So, and then we did not go over, because this was really focused on number, but spatial vocabulary. There are some early studies about how kids who are proficient in understanding and comprehending spatial vocabulary, like you see, are more mathematically inclined in other areas. So even more reasons to use math vocabulary around our kids. And then what I put in the square are words that seem to be tricky: in between, halfway, middle, left, and right. These are you know, trickier for kids to grasp. And that's it. Thank you.
You're welcome. Well, thank you, Anna. We have some questions that have come in that hopefully we can take another 5 maybe minutes and
sure
those. And I'm going to start with the first one, because I think many families who are at home trying to work with their kiddos, this keeps coming up, but it's from Anna, another Anna. It says, hello, I'm just curious if it's important that the teacher and their student needs to use the same manipulatives to use during online lessons. So when you're trying to teach, you know, a child online, it sounds like, should they be using the same manipulatives while you're trying to teach them back and forth?
Yeah, no, I love this question of online, because it's been a challenge even in my own practice, because like not all my students have these blocks, right? And so can I demo a different app?
Absolutely. And
yeah.
then, yeah. And if you can just turn the volume up a little bit louder on your computer, because a couple people have said they still have had a hard time hearing.
Okay.
A little faint.
So there's no audio for the app, but it's me. Can you hear me?
Perfect.
Okay.
Yeah.
Okay. So I'm going to stop sharing the iPad, and I will share this. So here's my iPad. I use Educreations, and so when I'm working with older students, and so I use pictures more than I do the physical manipulatives, but let me just show you some of the vocabulary. This equals 1, this equals 10, and a big square equals 100. And so if let's say we're working on dynamic addition, and I might have now that you know that X is 1, that line is 10 and square, I might, you know, ask them to add these things. And so the student will talk me through their thinking, right? They will say, well, I see 5 hundreds, and we'll group those together. And then they'll say, but I see 11 tens, and 11 tens, these tens equal another 100, right? They will then cross that out. And then I see 4 units. So then they have to use their language. It is hard. There are other manipulatives, virtual manipulatives. Let me see if do I have them? Yes, the math, I forgot who makes these. This is from, Math Learning Center. They have virtual manipulatives that are available on Android and iOS, and they're free. And so, and they have the web version too. I've never used that, but students could share, if they have the web version, then you can share your screen, or they can share their screen and show you how they're using the manipulatives. Does that answer that person's question? I
think so. I thought it was great. You know, another question that's come in around, when you're trying to teach children with ASD, problem solving, like if you're telling them a story and then them having to do problem solving, what are some different techniques for trying to teach kids with ASD or anyone when you're trying to do problem solving? I mean, what comes to mind for me is, so many kids with autism think in pictures, right? And so I think some of the things you were displaying is around that, but would love to get your perspective on that.
Yeah. So for some kids with ASD who are nonverbal, I give them multiple choice. So, and this is a perfect example. Like, I might have prepared materials in advance where they're matching the quantity of these cards, like this is 10, with the numeral 10. And then I will ask them to sort and match based on this, so that they don't have to talk. They don't have to tell me that this is 10. They can either hold up 10 fingers, or they can just hand me a 10 in numerals. And then, or I can say, hey, can you hand me the one that says 2? And they'll hand me 2. So the nonverbal kiddos, I try to prepare the lessons in advance to limit the language that they have to use, but also show me and demonstrate that they know what's being asked of them to participate in. And that's also really hard for oral counting. Oral counting circles for kiddos who are nonverbal are hard, but one way you can do it is you can count, 10, 20, 30, 40, 60, 80. And then they're like, oh no, wait, you get their attention. They're like, oh no, that's not what's supposed to come next. Mm-hmm. So that's also another indication that I'm like, okay, they've got some knowledge here. I have a student on the spectrum, and he is very verbal, and he has not been taught or hasn't practiced enough traditional algorithms. That's an area of growth for him, but he is so quick to calculate things mentally. It flies like, whoa. And his creativity in problem solving is just amazing. But if you give him a test on a computer, or a bubble-in test, a standardized test, he scores very low. But the moment you give him, kind of like that teacher didn't spoon feed the little boy who was playing the bears in the cave, she kind of let him sit back and think. When I gave this student time to think and space to talk through his thinking, that's when I knew, wow, he has a special way of looking at number that cannot be tested, but that needs to go in the report. It needs to, you need time to play these games and develop a relationship in order to tease these things out.
Yeah, I think this is another really good question. And I know that this has come up when you and I've done workshops together before, but what is the question is here from Jezel Ann. What would be the first step in teaching numbers? Is it the number recognition first, or is it the value, then learning how to write it? And I know like you've had a lot of conversations, like understanding you have to have the basics before you can move on. And so if you could answer that question, that would be great.
So when I'm when I'm looking at early learners, I really emphasize working with objects and using language. And if I have things pinned up around the classroom and it's the numeral 1 or 2 or 3, here, I'm gonna have to write this on my piece of paper and maybe it'll show up on the screen. You know, I'm purchasing either apps or printed materials that show both the abstract and the picture related to it, so that kids are exposed. It's okay to expose them to the numerals at birth. I don't care. But when I'm intentionally selecting things in my classroom, at home, I want to be mirroring. They need to be wedded for young learners.
When do you know when your child is ready to move on to the next phase? Because this is a question that we also received is, I have a child, it's kindergarten student, and already, he already understands like the basics of math and abstracts. So when is it really good in adding objects with pictures? So the kid is a kinder student. Is it all right for me to introduce him the basic operations in abstract because he already is good in objects and pictures?
Yes. So, but I'm explicit about my, and so these symbols, this is a whole different webinar, Lisa. Okay, yeah, these symbols, we'll a lot of people say this is adding. When you add two numbers together, they get bigger. I don't do that. I say this symbol means joining, I am joining numbers together. This is what that means. Here, this means two different things. This means taking away, but it also means comparing. Like your brother is 10 and you are 5. What's the difference? What's the difference in ages? That's what that symbol means, and we aren't explicit about what that means, but subtraction, this symbol means two different things. It's taking away, but it's also comparing. And this one is grouping, 2 groups of 3, or I have 2 plates of cookies and there are 5 cookies on each plate. That is 2 groups. That's what this means, of 5. And this is putting into groups. We are dividing into groups. Yes. And then this equal sign, lots of confusion and misunderstanding about equals. And a lot of kids, and I didn't know this, but tons of studies about how kids think equals means the answer. So I do a whole exercise on what that means. And we come to an agreement in class that equals means fair. It is fair. It is not equal if Lisa gets 5 candies and I get 3. That's not fair. No way. I want fair, or it's same as. So we do a lot of, without even the operation, 3 equals 5. No, that's not fair. That does not make sense, So yeah, I think it is okay to totally bring that and introduce that into your 5-year-old, but have those explicit conversations about what those symbols mean, because they're going to come to their conclusion if you just put some worksheets in front of them with abstract numbers and you model it and you say, this is what the answer is. They're going to come and make lots of assumptions. And so that's why I say I like to have explicit conversations about what those symbols mean.
The other question that's here, and it's, that, many people have issues with not having access to computers and gadgets, and, internet access is not always accessible, just leveraging, the things that you have around the house and I'm sure, Anna, you can probably, add to this, but it's like, pull out a deck of cards or use the pots and pans that are in the, I'm like, whatever it takes. Cause the question is, how do you teach fractions and, some of these harder math things when you get up there with these kids who, don't have access, and we're in this new norm. So any additional tips around just.
Yeah, I have a whole, I wish I could show you. I like to keep
Marbles?
these pebbles and marbles.
Rocks.
So rocks are totally fine. And there's plenty of games that include like Mancala. I don't know if that's a popular game where everybody's from, but it's one of the oldest games in the world, Mancala. And you play it with pebbles. And that's a great number sense game. And but so what do you use if you don't have computers? So my girls and they're at sewing camp, and they're learning fractions because they have to, they have a ruler, and they need to mark on the fabric 1/4 inch in, and they need to know what a 1/4 inch, or if you're in centimeters. They're also having geometry. It's when they practice spatial relationships of cutting out the patterns and matching the right sides together, or having to twist and turn and transpose. These are all ways to develop your superpower of math. And then cooking is one that I'm doing with my one of my high school students. She needed to convert a recipe because in the cans, she was making spaghetti sauce. The cans are 28 ounces, but the recipe called for 2 cups, but she needed to double it because her family is 8 people and not 4. So what does that all mean? How do we figure that out? 28 ounces, how many cans do I need to buy for 2 cups in the tomato sauce? But then I have to double it, so really that's 4 cups. And so this is where math and family and connection and community happen. And it's just, now you're intentional about it. That these moments are so precious that this is where the love is.
Yeah. Awesome. So with that, we went over a bit, and Anna, I want to thank you so much for your time. We will be posting this again. This is live now on our Facebook page. It will continue. So, any of the references that are in here, you guys can go back. You can re-listen to this over and over and over to get, all the different tips that Anna gave you. We'll also be posting it onto YouTube. And hopefully we'll be able to have Anna come back and do, another workshop with us in the future. But I do really greatly appreciate you taking the time, Anna, and, doing this for us. Somebody also asked the question about Toto Math. It is an app it is not a free app. It's
subscription.
Yeah, I believe there's so those of you who do have access, feel free to, look on the App Store. You can see the cost, etc. I think Anna shared a lot of other free, things that are out there for folks. And so with that, I think we're gonna close it out for the evening. Thank you again, everyone, and follow our Facebook page, because I will be posting in the next day or two another series that we'll be doing, which is a 5-week series with Dr. Di Malanta, who is a developmental pediatrician who is from the Philippines. And we're going to be doing a full series with him around the importance of play. So super fun. All right, everyone, thanks. Take care. Have a good afternoon, good day, wherever you are. And gotta hit the end. Bye, everyone.